Once again, welcome to the chemistry class. This is your chemistry sir. So in the last class, yesterday we have discussed about the colligative properties. There are four colligative properties. Among those, the first one is relative lowering vapor pressure. We discussed in the yesterday class. So today we are having that continuation. That is the importance of colligative property. Among four, the first one we have discussed and second one is elevation of boiling point. What is this elevation of boiling point? So you know about already boiling point and melting point. There are two. So here boiling point is nothing but keep in your mind whenever we are using the word, you just imagine the meaning of that one. Boiling point is nothing but what? In a beaker. In that, if I would like to know this one means I can't see the boiling point of this one because it is a solid. For the solid we have to check the melting point. The solid, it has to be converted into the liquid. That is called as the solid should melting point. With the boiling point, we have to take the liquid only, the liquid compound. When it moves to the liquid to the vapor state, that is called as boiling point. At what temperature the liquid is going to evaporate, that is called as boiling point. So why I am explaining this simple concept? Why? Because elevation of boiling point, here you should know the boiling point of two compounds. That is, one is solute, another one is solvent. So here let's know what is elevation of boiling point. Here elevation of boiling point is nothing but delta EB. EB is nothing but the difference of the boiling point of the temperature. That is delta EB. Here itself is the elevation of boiling point. So elevation of boiling point is nothing but it is the difference between the boiling point of the, I have written TB and TB naught. Can you guess here? TB naught is nothing but what we have seen in the previous PA naught. PA naught is nothing but pure form. A is the solvent. A naught is nothing but pure. PA is nothing but solution. The same thing here is also. P indicates the boiling point temperature. Temperature means T. P is nothing but boiling point. Elevation boiling point of temperature. TB is nothing but the solution. TB naught is nothing but the solvent. TB naught is nothing but the solvent. Keep in your mind, B is only for the boiling. P is the temperature. So can you see here how I have written this? The boiling point of the solution is greater than that of the boiling point of the pure solvent. So it means, how means, I said in the yesterday class, the water can easily converted into the vapor because it's a pure form. Water is only one solute. That's why it on boiling at 100 degrees Celsius, it easily converts into the vapor. Whereas when we added some of the solid, particularly non-volatile solid, because in the beginning we have observed the colligative properties nothing but which going to correlate only for the non-volatile solid. That's why we have going to develop only the molar mass of non-volatile solid only. So in the water easily vaporized, whereas the non-volatile solute which is present in the solution, it means solute plus solvent. In that condition, that solution not easily evaporates. Not easily evaporates is nothing but it should have the greater boiling point. It means solvent is having the lesser boiling point and solution is having the greater boiling point. So it means which one is having the boiling point? That means solution is having the greater boiling point compared to that of pure form. Means a solvent is can be easily converted into vapor. Therefore, the boiling point of vapor means the boiling point of the solvent is lesser. Means we need less temperature to make solvent, only solvent as a vapor. To make the solution as a vapor, the compound which is contained in the solution as a vapor, we need greater temperature. It means that the boiling point of the solution is greater than that of the boiling point of pure solvent. For that reason, I have written the formula TB minus TB naught. You are not supposed to write TB naught minus TB. Now you can guess here TB I have written first, TB minus TB naught. Why we have written this one means you should be capable to analyze your statement. So they are not going to ask, but you should know this one. If you know the basic things, you can't able to forget, you can't able to do any mistakes. For that reason, so delta TB, that is nothing but elevation of boiling point is defined as it is the difference between the boiling point of solution and the boiling point of pure solvent. This difference is called as elevation boiling point. Boiling point of solution, boiling point of solvent. These are having the difference. The greater one is solution and the other is pure solvent. This difference itself is called as the elevation boiling point. So this is the elevation boiling point. Next one what we have to do is by this expression we have to calculate the molar mass of solute using elevation of boiling point. So let's take calculation of molar mass. So here calculation of molar mass of solute, that is MB, that is the molar mass of solute using elevation boiling point. I said it in the last class only. EBP, elevation boiling point. This is for our convenient reality, not in the textbook. So here elevation boiling point, with the help of this we have to create the formula for molar mass of solute. Okay, so we know that delta TB is proportional to the M. M is nothing but mass of the solute present in the solution. Why? Because I said in the commutative property it depends on the number of moles of solute XB. It depends on XB. For that reason, the boiling point of solution increases. Why? Because due to the presence of non-volatile solute. For that reason, delta TB is directly proportional to the M. As M increases, delta TB increases. For that reason, I would like to replace this proportional by the constant, that is Kb. Kb is the proportional constant for this elevation boiling point. Therefore, delta Kb is equal to Kb into M. So, what will be the equation for M? M is equal to delta Kb divided by Kb. Is it clear? So, let's write the M. So, we know that in the last first use we have discussed about molarity and molality. Capital M is the molarity and small m is the molarity. Therefore, based on that expression, M can be written as WB into 1000 divided by MB into WA. This is the capital W. You are not supposed to write the small w. You have to write here small m is the molarity. The formula is WB into 1000 divided by MB into WA. Capital M, capital W you have to write. Keep in your mind. You are not supposed to write small. If you are writing small, it's wrong. So that is equal to what is delta TB divided by Kb. That is fast. What you need? You need MB. Just send WB upon MB as it is. You just take this MB to this side. What typically happens? Delta TB into MB is equal to, you just put this KB to this left side. Therefore, WB as it is into KB into 1000. Are you getting this one? So here I am sending this MB and WB also here. WB and MB will be to the numerator. KB into MB into WA. MB into WA. This KB we are taking this left side. KB into WB into 1000. So we need the MB value. Therefore, MB is equal to what happens? MB is equal to, you write the right side as it is, WB into KB into 1000 divided by WA into delta TB. So delta TB first I will write into WA. I will get this expression. So this is the molar So whenever they are asking you calculate the molar mass of the solute, they will not tell you only the molar mass based on the criteria which one they are giving you. If they have given the boiling point, both of the elevation boiling point. If they have given the vapor pressure, both of the vapor pressure and so on the MB. The same thing we have to continue for the next still two properties of colligative properties. I am getting this one. Elevation boiling point is nothing but there is a definition difference between the boiling point of solution and the pure solvent. So based on this expression, we are calculating the molar mass of solid, that is MB is equal to. So I think you can able to define the terms. M means molar mass, W means given mass, delta T means given elevation of boiling point, Kv is the constant, whereas A is the solvent, D is the solid. You should know this one. Simple answer. So this is about the second term. So we will move for the next one, that is depression of freezing point. So the third one is depression of freezing point. So depression of freezing point is a third colligative property. So this colligative property is going to explain that the freezing point between the temperature which is having the difference between the freezing point of solvent and solution. Here freezing point of the solvent is greater than that of freezing point of the solution. This difference between the temperature difference between the freezing point of the solvent and the solution is called as depression freezing point. Depression of freezing point. So are we getting? So this is the difference delta TF. So in the last we have seen that TP, B is nothing but temperature boiling point. Here F is nothing but temperature freezing point. So here and there we just look at the difference. There we have written TP minus TP naught, where here it is TF naught minus TF. So using this expression we have to derive the molar mass of solute once again. That is molar mass of solute is nothing but MP. We have to derive using depression freezing point. DFP is nothing but depression freezing point. So look here, to derive the molecular mass of the solute. So delta TF is nothing but here also depression of freezing point depends on the number of moles or mass of the solid present in the solution. Therefore, delta TF proportional to MP, proportional to M, that is mass of the solid. So I would like to change proportional by some constant. That is here I have taken Kb. Now I will take the F, constant of freezing point Kf into M, where M is equal to the formula delta TF divided by Kf. I hope from here you can able to easily do the same thing as we did in the last. M is nothing but molar Vb, that is Wb into 1000 divided by Mb into Wk, that is equal to delta TF divided by Kf. So what will be the formula? Mb is equal to, you just take the reciprocal Mb. I would like to send this to that side. So what will happen? Directly I am writing. If you want, you can write another step here. Mb is above. Mb is here. Therefore, Wb into Kf. Mb moves here and Kf comes here. Wb into Kf into 1000 divided by delta Tf comes this side, delta Tf and Wl is there. So this is the one. If you want just to box it here, the previous boiling point and this is elevation boiling point and depression boiling point. These are having the both formulas are almost similar. Instead of Tf, there we have taken as Tb. Here Kf, there it is Kb. Nothing is changed. Only the constant and the freezing temperature are changed. So this final expression is important. Based on this, we are going to derive the problems. So this is the expression. And fourth one is osmotic pressure. The last one is osmotic pressure. So here the osmotic pressure is the last colligative property in the four properties. So here osmotic pressure, what is that osmotic pressure? Before I explain you the what is osmotic pressure, let me explain some of the terms so that you can easily understand the osmotic pressure. So here some are more important, some are less important. So let's begin from the first one. So what is osmosis? Osmosis is nothing but it is the process of converting a spontaneous movement of the particles from lower concentration to the higher concentration. This diagram only for your understanding purpose. Think that here the solution is there, and I would like to call this is the membrane. This is membrane. Membrane is nothing but you already some students know the membrane, cell membrane, animal membrane, just like a wall. So that wall, just like a skin. Skin is one of the wall. So it can transfers the heat from body. When we sweat, water is coming from the body. But when we put some of the water on our hand, the water is not going inside. Only output is there, not input is not allowed in this wall. Similarly, wall that is called as membrane. Membrane is nothing but one of the wall. But this membrane going to pass some of the particles, means which are having very small particles, but it's not passing the larger particle. So this membrane is called as semi-permeable membrane, which it will not transfer every particles, it will transfer only the particles which are very small in the size. So look here, what is osmosis? Osmosis is nothing but it is the process of movement of solvent molecules from the solution of lower concentration to the higher concentration. This process is called as osmosis. So this is happening through the semi-permeable membrane. Semi-permeable membrane. So what is this osmosis? Very simple. Just to put one tomato in the water. So initially the tomato is solid, means it is not having that spongy. It's just similarly solid. ಮೆತ್ತಗಿರಲ್ಲ, ಟೊಳ್ಳ ಥರ ಇರಲ್ಲ, ಇಟ್ಸ್ ನಾಟ್ ಹೋಲೋ, ಗಟ್ಟಿ ಇರುತ್ತೆ. ನೀವು ವಾಟರ್ದಲ್ಲಿ ಹಾಕಿದ ತಕ್ಷಣ ಆಫ್ಟರ್ ಸಮ್ ಟೈಮ್ 1 or 2 hours, after 1 day, that the water molecules which is present in the tomato is shifted in the water molecules. So transfer ಆಗುತ್ತೆ ಸೆಮಿ ಪರ್ಮೇಬಲ್. ಇಟ್ಸ್ ನಾಟ್ ಕಂಪ್ಲೀಟ್ಲಿ ವಿತೌಟ್ ಎನಿ ಹೋಲ್, ಇಟ್ಸ್ ಟ್ರಾನ್ಸ್ಫರಿಂಗ್. ಅಂದ್ರೆ ಮೆತ್ತಗಾಗಿಬಿಡುತ್ತೆ. ನಾಟ್ ಓನ್ಲಿ ದ ಟೊಮೆಟೊ, ಯು ಕ್ಯಾನ್ ಪುಟ್ ಎನಿ ಆಫ್ ದ ವೆಜಿಟೇಬಲ್ಸ್. ನೀವು ಗೋಡಂಬಿ, ದ್ರಾಕ್ಷಿ ಏನಾದರೂ ಇಟ್ಟಾಗ, ಸೊ ದೇ ಆರ್ ಮೂವಿಂಗ್ the particles which are present in these vegetables or fruits, these are transferring to the water from their compound. So this is a kind of osmosis. Osmosis, it is undergo the transformation continuously, that's called as spontaneous movement of the particles from lower concentration to the higher concentration through semi-permeable membrane. This is called as osmosis, the movement of the particle from lower concentration. Keep in your mind, this is called as lower concentration. From lower concentration to the higher concentration, the particles are moving through the semi-permeable. Semi matlab it's not transferring everything. Semi matlab only half, little. Semi-permeable, permeate, it's allowing. Semi-permeable. Semi-permeable membrane means it is allowing only little compounds. That is, it is allowing only the solvent, not the solute. The osmosis is nothing but the solvent molecules which undergo the transformation from lower concentration to higher concentration through semi-permeable membrane. This process is called as osmosis. So what is semi-permeable membrane? The membrane which is allowed to pass only the solvent particles but not the solute particles. Means only the smaller particles are allowed to pass through it but not the larger particle. That membrane or that wall itself is called as semi-permeable membrane. It permits to pass only semi, means only little compounds are passed. That is called as semi-permeable membrane. According to me, what is osmosis? This is important. They will not ask you this semi-permeable membrane. Whereas this one is very much important. Osmotic pressure, that is what we are discussing as the fourth colligative property. Osmotic pressure, that is represented by the pipe. We know that it's not related to the physics or mathematics. Pipe. It's only the osmotic pressure. Only here we are taking pi according to this only this expression. Pi is nothing but osmotic pressure. What is this osmotic pressure? Look here, this is very simple concept. We know that osmosis is nothing but the solvent should transfer from lower concentration to higher concentration through semi-permeable membrane, that is called as osmotic pressure. Here we are going to apply some of the pressure so that osmosis should stop. Osmosis should stop. So think that the concept, the solvent is moving from lower to higher, so that we are applying some pressure here. We are applying some pressure. Think that it is just imaginary. We are applying some pressure. Where we are applying? We are applying on the higher concentration. Why? Because the lower concentration to higher concentration, the particles are coming, so that we don't want to pass this. Means we want to stop this osmosis. For that reason, we are applying the pressure on higher concentration. Means osmotic pressure is the pressure applied on the higher concentration just to stop the osmosis. That is called as osmotic pressure. The pressure applied on the higher concentration to stop osmosis. This is called as osmotic pressure. Are you getting my point? The pressure where we are applying is at higher concentration just to stop the osmosis. Why? Because it's coming from lower to higher. For that reason, this is called as osmotic pressure. Keep in your mind, this is most important. According to me, this is the very important. What is osmotic pressure? They will ask you. And similarly, the second means third one, this is also the most important. Define reverse osmotic pressure. What is this reverse osmotic pressure? This is also same thing. Look here. Initially, some pressure will be there on the lower concentration. For that reason, the particles are moving from lower to the higher concentration. This is called as osmosis. Are you getting? If the pressure applied on the higher concentration to stop the osmosis, so that the pressure applied on the higher concentration should be equal to the pressure on the lower, so that there is no transferring. If transfer means, that is called as osmosis. If it is stopped means it do not undergo the osmosis. Are you getting? What is that? Reverse osmosis. Reverse osmosis means it should take the osmosis process in the reverse direction. It means that the particles should transfer from higher concentration to the lower concentration. When it moves means when we apply the pressure on the higher concentration greater than the osmotic pressure. Osmotic pressure means we are applying the pressure only to stop the osmosis. Only to stop the osmosis. The same osmotic pressure when we apply still more greater, still more higher, and at that moment, that situation, that osmotic pressure itself creates the reverse osmosis. Reverse osmosis. That pressure is called as reverse osmotic pressure. So reverse osmotic pressure is nothing but the pressure applied on the higher concentration greater than that of osmotic pressure, just to reverse the direction of osmosis. That is from higher concentration to lower concentration through semi-permeable membrane. That pressure is called as reverse osmotic pressure. Reverse osmotic pressure. If we ask simply the reverse osmosis means, reverse osmosis is nothing but the solvent particles which are moving from higher concentration to the lower concentration through semi-permeable membrane by the presence of reverse osmotic pressure is called as reverse osmosis. Are you getting? The concept is very clear. According to me, I am not going fast. If you feel means, please divert that one and try it once again. And this is very important for me. According to me, these three concepts are more important for your examination point of view. And remaining these are, I don't want to say these are the useless, but these are useless. Instead of useless, we are using that one, but what quantity we are using, that is less. For that reason, these are used in less, used less. So somehow I will tell you, isotonic. What is pressure? What is or define isotonic pressure? Iso is nothing but same. Isotonic pressure is nothing but somewhere we are taking two solutions. If the two solutions, the two different solutions are having same pressure, then it is called as isotonic pressure. If the two different solutions are having same pressure, then it is called as isotonic pressure. What is hypertonic pressure? Iso, this is hypertonic. Next one is hypotonic. I think you know BP, low BP, high BP, hypertension and hypotension. Hyper is nothing but greater BP. Hypotension is nothing but lower BP. BP is less than larger. Similarly, hyper means greater, hypo means lesser. So hypertonic pressure is nothing but same thing. Here also we are taking the two different solutions. Between the two different solutions, if one is having the greater pressure, such solutions are called as hypertonic pressure. Between two solutions, if the both are having the pressure, if one which is having the greater pressure, that is called as hypertonic pressure. Between the two solutions, both are having the pressure. Which one is having the lesser pressure, that is called as hypotonic pressure, isn't it? So you can remember this one, but don't forget these three, which one I highlight. This is the most important. So coming to the colligative property, the last one is osmotic pressure. I hope you can able to understand this one. Osmotic pressure is nothing but it is the pressure when applied on the higher concentration to greater than the osmotic pressure. Just here, osmotic pressure is the pressure which is applied on the higher concentration to stop the osmosis. Osmotic pressure is the pressure which is applied on the higher concentration to stop the osmotic pressure. So this is about the osmotic pressure. So next is calculation of molar mass of the solute. Here also using the osmotic pressure. Let's start that. The last expression, that is calculation of molar mass of the solute using osmotic pressure. So here osmotic pressure is nothing but by osmotic pressure how it varies with the molar mass. But we are taking here osmotic pressure is proportional to the concentration. Concentration is nothing but how many moles or the solutes are present in the solution. That is nothing but concentration. So pi is directly proportional to C. C is nothing but what? Concentration. But we can replace pi. Proportional can be changed by the constant, that is K. Same writing as the where this constant is depends on the two terms. That is R is a gas constant, T temperature. Based on R and T, the constant can be very easy. For that reason, I am replacing the K as R and T. And C is nothing but concentration. The concentration of the solution can be represented by the M, because M is nothing but molarity. Therefore, R T, M can be written as NP divided by P. NP is nothing but number of moles of the solute divided by volume. Therefore, pi NP can be written as pi is equal to R into T NP divided by P. Whereas NP is nothing but what? WB divided by MB. WB divided by MB. That is, here I am writing WB can be written as I have written WB divided by MB. Therefore, MB if comes here, MB is equal to RT WB divided by pi into B. This is the final expression. So, I hope you can able to understand now. MB is nothing but mass, molar mass of the solute. Gas constant is the temperature. WB is the given mass of the solute, and this is molar mass of the solute. Pi is the osmotic pressure, P is the volume of the solution. So keep in your mind, among these four colligative property, they will never ask you to derive the molar mass of the solid. Probably they will not ask you, but they didn't ask you anywhere. But you should know how we have calculated these one things. But for the examination point of view, we are going to use only the last final expression, that is in the problems are important here. So without fail, you should be remember the final formula. You have to remember this one to solve the problems. Okay, so still one or two some definitions are there. Some of the portions they have reduced. I hope you know these one things. In the notes I am sending everything, but I will tell you which one is there, which one is not there. So if you want, you can write everything, but keep in your mind which is there, which is not there. If that not there, it will help you in the competitive exam. For that reason, you can write it. But for explanation point of view, I may explain little bit less because it's not there for your analysis. for the present. So up to here it is there. Remember the final expression. So we will meet in the next week. If possible, we will start the problems on the next classes. Okay, we will see on next week. Bye.